Let's dive into reinforcement learning in the context of training large language models using the analogy of going to school and working with textbooks. Training LLMs can be seen in three major stages, much like a student progressing through their study. First, there's pre-training, which is akin to reading all the expository material in textbooks across various subjects. During pre-training, the model is exposed to vast amounts of text from the internet, allowing it to build a broad knowledge base and understand the statistical patterns of language. This stage results in a base model, which is essentially an internet document simulator. The second stage is supervised fine-tuning, which is comparable to looking at worked solutions in a textbook provided by a human expert. In SFT, the base model is trained on a curated dataset of conversations between humans and an AI assistant, where human labelers provide the ideal assistant responses to various prompts. The model learns to imitate these expert demonstrations and adapt the persona of a helpful, truthful, and harmless assistant. While SFT is crucial for tuning a base model into an assistant, it essentially relies on imitation of human-provided data. The third and final major stage is reinforcement learning, which is like doing practice problems in a textbook where you are given the problem description and the final answer, but not the step-by-step solution. In this stage, the LLM gets to practice generating responses and refine its behavior based on feedback. The model explores different actions, receives reward signals from its environment, and updates itself to maximize those rewards. Over time, it improves through this feedback loop. It's not pure trial and error, but rather guided optimization based on the outcomes it experiences. Here's how reinforcement learning works for LLMs, drawing on the analogy we used so far. The first step is prompt and candidate solutions. Similar to a practice problem, the LLM is given a prompt, the problem statement. The model then generates multiple different solutions or token sequences in response to this prompt. Because these models are not deterministic, each attempt to solve the same prompt can result in a slightly different sequence of tokens. The next step is feedback and reward. Unlike SFT, supervised fine-tuning, where the model learns from expert-provided solutions, in reinforcement learning, the model receives feedback based on whether its generated solution is correct, achieves the final answer, or desirable according to certain criteria. For verified domains, like math problems, where the answer is concrete, for example is 10, the model can be automatically assessed. Solutions that lead to the correct answer are rewarded or encouraged. Finally, learning and improvement. By trying out many different solutions and receiving feedback, the model learns which token sequences are more likely to lead to the desired outcome. It adjusts its internal parameters to favor the successful paths and discourage the unsuccessful ones. This process allows the model to discover its own effective strategies for problem solving, which might even differ from how a human expert would approach it. Reasoning models like OpenAI O1 or O3 have been trained using reinforcement learning. Note that pre-training and supervised fine-tuning have been around for years, and all LLM providers do them. However, reinforcement learning is new and not standard yet. You've got an idea now of how LLMs become so smart. We are taking a quick break, and in the next lecture, we'll dive into something truly transformative, becoming better than humans. AGI and ASI with reinforcement learning.